Okay, part two. Now what you see here, I lied. I didn't hook this up yet. I wanted to show you. This circuit, just like the original single stage Tate, also works as a very, very efficient line noise harvester. So our input now, our positive input, which should have been the antenna, is now my house grounding. And the ground here goes to a real ground rod. This is running over, blah, 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 outside the door over there to a ground rod pounded in the ground. And as you can see, we can harvest the line noise that is on the circuit through the house. The only thing plugged in at the moment is, or running at the moment, is that fan. And I think I do see some fluctuation when I turn it off. Actually, it gets higher here. It's so hit or miss because the line noise is unpredictable. Stuff could be running in the house, you know, the furnace kicks on or the air conditioner, blower motor, etc. Causes line noise, backfeeding, spikes and whatnot. And that surge can be recovered with just the Tate by itself, or the extent of this, we'll call it the Quad-Tate for lack of a better term. So there's that. You see we usually climb to 5 volts. I'll discharge it and see how fast we climb right back up there. Now this could definitely charge a battery. In fact, here is a 6-volt battery, and let's see, I got it ground. Let me discharge it, and the battery's got about 2.5 volts on it. It's half dead, so you can see that we can still climb and slowly charge this battery just from the line noise from the house grounding and the earth rod being harvested through the Quad-Tate ambient harvester. Always mark your diodes if you're going to use these bridge rectifiers. It's a pain in the butt to try and figure out without marking them. Okay, so now I will, for real this time, hook up that and show you the real capability here. And we're back. Okay, so now capacitor is discharging. Short it out. Hot wire is actually live through this. The switch is off. It's actually switching the ground wire because I think this plug is wired backwards because it's AC and it didn't matter. So even though this connector I parted out has a black wire coming off of it, and that's what's going to the switch and to the black wire on the ballast, it's actually neutral. Go figure. So when I flip the switch on and this ballast starts feeding the 2 kilovolts at whatever hertz into the input of the Tate, the ambient Tate harvester, this is our storage bank here. This is just in parallel with the direct outputs on either side out there. So you'll see what happens on the voltmeter. Instantly off the scale. This meter only goes up to 600 volts. So it's way over 600 volts DC. So I'm going to turn it off and give you a little discharge. Hold your ears now. Woohoo! Look at that. Oh, look at that. It's climbing back up. Yep, there it goes. Okay. I'm going to unhook my meter so that I can not blow it up for a second. Hold on. Okay, meter's unhooked. Same as before. That's turned on. I hooked up I think this is a 100. It's all worn out because I've fried this thing too many times. It's a 100 watt bulb. You can't read it. It's just barely visible. 100 watt bulb, 120 volts, coming right off the output. I don't have that storage capacitor hooked up because I didn't want to hook it up yet. So there's one example. Significant amount of current is able to be recovered from this circuit, even though that's probably not the amount of current that's actually coming out of here. So that's the interesting thing. It almost doesn't seem like it's adding the voltage, but instead it's magnifying the current. So let's pause one more time and we'll hook up the light show. Okay, so now here's what we've done. Taking the output of the Quad-Tate ambient harvester, and we have one going to this 12-volt ignition coil, and going through another 5 microfarad capacitor as a sort of DC reactance. Now, and then back into the other side. We have a spark gap that is going to be used to directly short the DC reactance capacitor. So no current can flow through there because of the capacitor until a voltage breakdown occurs on the spark gap. And when that happens, it shorts those terminals, basically eliminating the capacitor. Or is it? And then the field can collapse. The field rises up on here and then it can collapse, and that's when we get a good action on the secondary. Now what you're going to see is the sheer volume magnitude of energy that is being discharged here. It's quite remarkable. I'll bring it all the way in. All the way in. This is the shorted gap phenomenon, where the carbon seems to allow breakdown and vibration. WD-40 really plays a good role in allowing the shorted gap to function a lot better, at least temporarily. But as we bring the gap out, you can see that they're not touching anymore. The voltage is still breaking down. I'm going to bring it out really far. And as you can see, the voltage still climbs up enough to bridge that gap after a few moments. And we get quite a surge at that point. Alright, I got it out too far. Oh, there we go. So as you can see, it's out a good 1/16 of an inch, perhaps. So what I'm going to do is I'm going to take it all the way out, and I'm going to let this little guy right here charge up almost to the point of rupture, if it would actually happen, and show you what happens when I go like this. Ready? How about that? Ow, that hurts my ears. Quite remarkable. That's a hell of a surge right there. This, in conclusion, the quad stage ambient Tate harvester module, Overdriven, has quite the potential for providing a significantly suitable high voltage DC power source. Which is what we're after. Stay tuned for perhaps tomorrow or later this evening. We shall drive these guys with the output and just see how much better results we can get out of some to be determined conglomerated combination of resonator step up. Pretty neat, huh? That's a lot of shit.